Hello friends, this video on P block elements part 13 is brought to you by examfear.com. No more fear from exam. Let's see how this group 15 elements react with halogens. So again, they react with halogens to form two types of halides. And these halides are of form EX3 or EX5, where E is any of these elements in the group 15 and X is any of the halogen elements, fluorine, chlorine, bromine, iodines. Okay. Please note the nitrogen won't form NX5. NX5 is not possible in nitrogen. Why? Any guess? We just discussed. Yes, covalency. The nitrogen won't find NX5 because of the non-availability of d orbitals, and it can have maximum covalency of 4. Okay. So we talk about some example of X3. I can have example of NF3 one example, PCl3 is another example, ASCl3 is another example, SbCl3 is another example, BiCl3 is another example. Talk about EX5, this is X5, sorry. So example can be PCl5, ASCl5, SbCl5 and BiCl5. Anyway, this is unstable. But you see NCl5 is not even there. Okay. And if you talk about the structure, these EX3 have the structure of tetrahedral. And these EX5 have the structure of trigonal bipyramidal. That is a structure. And these MCl3 which we have, or ECl3 or EX3 we have, these are all hydrolyzed by water. You see that? These all MCl3, LCl3 I'm talking about, they are hydrolyzed by water. For example, if we talk about NCl3, nitrogen trichloride, it will react with water to form my ammonia and HCl. Similarly, PCl3 will again react with water to form H3PO4 and HCl. My arsenic Cl3 will also react with water to form H3ASO3 and HCl. My SbCl3 will also react with water to form SbOCl and HCl. Similarly, BiCl3 again stable compound reacts with water to form BiOCl and HCl. They all react with water. Okay. So as I have told, nitrogen is always special. So let's study the stability of all NX3. X can be my fluorine, chlorine, bromine, like that. So we talk about the first halogen, that is fluorine. NF3 is stable. We talk about NCl3, that is explosive. We talk about NBr3, fluorine, chlorine, bromine, and then iodine. These are very explosive. Now you must be wondering why. So let's see the electronegativity that has the answer. Nitrogen has the electronegativity of 3.04, fluorine has the electronegativity of 3.98, chlorine 3.16, bromine 2.96, and iodine 2.66. So if you see nitrogen and fluorine, there is a difference of almost 1. So they'll form partial charge and they'll form a little stable structure, right? NF, F, and F. Fluorine is more electronegative. Fluorine will get slightly negative, slightly negative, slightly negative, and slightly positive charge. So slightly positive charge on a atom which has lone pair, it adds to the stability. So this is little stable. But if you talk about the chlorine, the difference is not that much, so it will not get that much positive charge. Nitrogen will not have that much positive charge, so it won't be that much stable, it will be explosive. And in this case, if you see, nitrogen is more electronegative than bromine and iodine. So nitrogen already had a negative charge, and it will have all the more nitrogen already has a lone pair, plus it has negative partial charge, and this fluorine and bromine, the size is little big, so actually what happens is it becomes very unstable, it becomes very explosive. Now we'll talk about the reaction with other metals. See, these group 15 elements, they'll react with metals to form binary compounds, and they'll exhibit -3 oxidation state. For example, Ca3N2, -3 oxidation state. Calcium nitride, Ca3P2, calcium phosphide, Na3AS2, right? It is my sodium arsenide, Zn3Sb2, zinc antimonide, Mg3Bi2. This is my magnesium bismuthide. These group 15 elements, they'll react with all these metals. These are all metals. They'll react with this metal to form binary compounds, and they are generally nitride, phosphide, arsenide, and they have -3 oxidation state. Though nitrogen exhibits +5 oxidation state, it doesn't form pentahalide. Why? See, pentahalide is what? px5. To form px5, it needs oxidation state of +5, that is okay, but it needs covalency of 5. But covalency of 5 is not possible in nitrogen. Why? Because it doesn't have empty d orbital, so it is not possible. But oxidation state of +5 is possible, right? That is okay for it. We have seen, for example, HNO3. Here the oxidation state is +5. Let's see the shape of HNO3. HNO3, this is the shape of HNO3 actually. Yeah. So if you see, the covalency is 1, 2, 3, 4. The maximum covalency allowed is 4 because of the MCD orbital. The oxidation state is not linked with covalency. It can have oxidation state of -3 to +5 that we have seen for nitrogen. pH3 has a lower boiling point in ammonia. Why? We have seen this. See, ammonia has a hydrogen bond. Because of the difference in electronegativity is more, so nitrogen gets slightly negative charge, slightly positive charge, and it forms hydrogen bond. But pH3, the hydrogen bond is not there. So NH3 has hydrogen bond, pH3 has no hydrogen bond. And the answer lies in electronegativity. We have explained that, right? Though the electronegativity difference between nitrogen and hydrogen is there, it is so it develops slightly negative charge, slightly positive charge, so you have the hydrogen bond here. Here the electronegativity difference between phosphorus and hydrogen is not that much, so no hydrogen bond. So no, in this case we have a hydrogen bond, so the melting point and boiling point is more. Correct? Because it has to break the hydrogen bond. In this case, no hydrogen bond, so melting point and boiling point is low. The next is, why are pentahalides more covalent than trihalides? So pentahalides are px5 and trihalides are px3. So in this pentahalide, you see 5 electrons are shared. In this 3 electrons are shared. So covalency, 3 electrons. Covalency is all about sharing electron. So first answer you can give is, in this case 5 electrons are shared, in this case 3 electrons are shared, more sharing in this px5 case, so they are more covalent. That is one solution. The other one is the polarizing power. If you see is px5, the oxidation number is +5. Or px3, let's suppose, the oxidation number is +3. Correct? Now since oxygen, say the phosphorus is +5 oxidation state, it has more polarizing power. This is +3 oxidation state, it has less polarizing power. Since px5 has more polarizing power, it is more covalent. Why? Because as per my Fajan rule, higher charge on cation implies more polarizing power and this internally implies more covalent nature. So you can view this from two perspectives. One is you can say that more electron shared, so more covalent nature, or you can say that this has +5 charge, this is +3, plus more higher charge on the cation, that implies more polarizing power, and more polarizing power implies more covalent nature. Fajan rule. The next is why BiS3 is the strongest reducing agent among all the hydrides of group 15. See, as I told, as you go down, the stability of hydrides decrease. Stability of hydrides decrease as we go down the group, right? So you can say that BiS3 is not stable. Since it is not stable, it will have more reducing capacity. It's not stable, correct? More reducing capacity means it will oxidize itself and it will reduce other metals. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.